Thank you for your attendance today. And yes, we're going to review what's new in OpenBridge and OpenTunnel 2024. There's a lot of enhancements. We are trying to squeeze all of them within the hour. Our usual disclaimer statement. And well, OpenBridge. OpenBridge 2024, again, this is the technology stack in which the software is built. We're using the latest MicroStation platform, version 24. And as well as the civil platform, OpenRoads and ProStructures. So certified on 2306 for ProjectWise, connection client 23, as you can see. So let's start. First one, deck contours, right? Yes, we have deck contours now because before we couldn't generate it, right? And if you wanted to generate it, well, you have to plot some points, ASCII files, build a terrain using XYZ from the deck elevations report, many different options. But yes, it was a kind of a extensive learning because you need to know how to build a terrain. So now the terrain is created automatic. So it's a terrain element, right? So as soon as you create the deck, and of course using the elevation, the alignment, the profile elevation, and the deck slope, it will just create a terrain element. So it's part of the deck feature. So yes, you have it automatically, and it creates a deck surface. So you can use all the other points. It's just a regular terrain, and it's generated automatic. If you don't want this to be generated, well, there is a config variable that you can set up and avoid that. Because every time you modify something on the deck, that terrain will get generated automatically. So as I said, it was part of, as you can see in the video, is part of the deck properties. So I got deck 1 on mine, and that is the top surface model. That's what it creates from the top surface. And well, it's just his own feature. You can activate, deactivate the display. Now, to control the generation of the terrain, the contour spacing that you want is through an element template that is being used to do this calculated feature. Again, it's treated like any other terrain, as you used to do in OpenRoads, for example, when you create one. So all of that is created automatically. And as I said, this is done through an element template, all the configuration of contour spacing, contour symbology, and the generation itself, what elements are displayed right as you create them. So if I go to the drawing production tab and check on the element template that is created right on the DGN itself. So this is where you control that definition. Okay, the display and the calculated features is for the contour space. Okay, now what other one we have? The controlling deck elevation, right? The name says a lot, but what is that? Well, we create the deck, but again, some users want also to create or display a wearing surface, and they use it for quantities purposes too. So basically, they create two decks, right? And the software we're using to compute the reference elevations for the beam layouts and all of that, for the last place deck. So actually, it was computing that for the wearing surface. So now you can specify, right, or the deck being used now is the last deck, or the deck with the lowest elevation, if I can explain it better, right? So all of that is created, and then the software, it will pick automatically the lowest deck elevation, right? Before, as I said before, it was the last place deck. So if you place, for example, some users were also placing sidewalks as decks, right? Or smaller decks. So to place a beam after that was very difficult, to say the least. So now it's just automatically place the deck using the lowest deck being in place. So nothing to set up there. It just does it automatically. So giving you the advantage to specify sidewalks as we used to do all times. Now we do it with barriers, or just to specify different layers of the deck itself, like wearing surfaces. Okay, so that's Now, what we have done with approach slabs, the approach slabs now, we can always apply it at the beginning or end of the bridge, right? But now we can also apply the super elevation uh, being done in open roads, right? Before, in previous versions, the deck was the only one available, the only one able to do that. But now, on the approach slabs, we actually have to create a super elevation table to mimic that. So now we can assign a super elevation directly to the approach slab, the same one that you assign to the deck, and it will just accommodate to that. Of course, the reports are updated, and so it allows you to do that way much easier now. Now, for the sleeper slabs, right? On the sleeper slab, usually it's vertical, right? But then again, the approach slab was also going through a slope, especially when you go into a profile slope situation, right? So it's a minor update, you would say, but it was actually require microstation modification to accommodate to this, right? So that was the sleeper slab before, straight, but now it automatically reacts to the slope when the approach slab is coming. So um, not much to do there. I mean, it's fairly automatic, right? But we have the toggles to accommodate to these fairly automatic. Right? So again, it may seem simple, right? But then it require before manual manipulation in microstation to do that. And of course, you know that if you apply microstation to the solids, then you may lose some, if not all, the parametrics there. So just a matter of placement, and it will just accommodate automatically to the slope. Right? So it's I zoom very close, you will see how it's flush perfectly with the approach slab. Okay. Now, another enhancement here is the steel beam elevation schematic drawing. Wow, such a long name. But yes, when you do a steel bridge, right, you sometimes not sometimes, most of the time, we got to do schematics along the beam elevation on the not only the plate sizes that we use for the built-up girders, but where we located the cross frames, where the fill splices or stiffeners are located. And this would require massive labeling, drafting, right, to specify every location. So, and it was a manual process. So now what we did is you can pick any beam in your bridge and generate automatically that elevation drawing with all the locations of that particular elements. So it creates a new uh, model, a 2D model. So it's ready to be, annotated. It allows some exaggeration because, again, to show a very small thickness plate, you need an exaggeration, so you can specify that. And the line work that is generated, it's linked to the actual level symbology or in the bridge, in the 3D model, right? So very simple here. So you just go to reports and drawings and just select the steel elevation on that beam group. What beam type you're going to use, you use a dimension style that is defined already in your configuration. And just go to the models and you will see elevation steel bridge 1 on beam number 1. So all that elements, the blue ones are the location of the cross frames, for example. You got the support lines and the different thickness that you can label now. Right? So caveat, this drawing at this time is disconnected to the bridge. So any updates on the bridge, you will need to regenerate this or apply this option again. Okay, so that's our steel beam elevation drawings there. Right? Now, some enhancement in geometry, right? The beam layout shortcut option, right? When you are doing a pre-stress girder and you want to place girders on a curve alignment, right? So if the curve is long, So, or the big radius. So the only way before was to using the long cord. So that was a little difficult to place when we go span by span on a pre-stressed girder, and we need to use just that distance between the two support lines. So that is the short cord on that Y curve. So now there is a new option in the beam layout in which we can use that, right? And this is measured span by span, right? So it's just another option. Like here, for example, on the beam layout, that is the short core option, right? I mean, I'm sorry, this is just a regular beam placement, but if I want to change this to the short chord, so you will see how this is, that's a long chord, for example, right? How this is aligned. So just to show you what I mean by the long and short chord. So see, that beam was placed using the geometry of the entire curve. So, well, as you can see, that was not that easy to place or not feasible to place. So now we use the short chord, and it's just being calculated, the beams span by span, right? And then you can add your distances based on that. So that is one more option for your geometry on the beam layout. Long chord, so you see that's not doable. So with the short chord, it allows me to specify separate beams at different distances. And so it's a matter just now to adjust your geometry there. And the distance is measured from the chord, as you can see. Now, also we have the beam flange decorators. So we have our beam layout, the center line of the beams as a decorator, right? The elevation 0 on the 2D view. So, but then in some framing plans, not only on concrete, but also on steel, we wanted to show, or they wanted to show the actual thickness or the flange of the beams, either concrete or steel, as you can see in the pictures below. So now we do it automatically. We have created a new beam outline decoration. So one more time, this is automatic. Still, you got the center line. So, but if you want to show the flange, it's also just part of the level symbology there. So when you place beams, right, it will, like I'm doing here, steel beam, like for example, when I just create some widths here. So not only we get the center line as we place the beam, but as a decorator, we are going to have the width of the flange. And if of course, if the flange varies, we're going to see that variation in the 2D view as well. Right? So if I added maybe a different width here, just to illustrate the concept, right, with a variation there. So see, now it's here. Better. See how it's changing? So we can specify that now. Something also on the labeling that will help us on the reports, it's the ability to rename the beam groups during the beam layout, right? So on this option, we label beam group 1, beam group 2. Now you can just go into your beam groups, each beam group, and just rename the beam group that you're placing, maybe span by span if you want. So you will just generate your reports, of course, using that beam groups rather than where is beam group 1, where is beam group 5. So we can specify now the name of that beam group. So it's going to be a little easier to read the reports that are being generated too. So just that simple, but powerful, as you can see. Now, this is something that a lot of DOTs do, and they call it dapped ends or beam notches as well. So at the top, at the bottom, or at the top of the beam, you got the option to specify these cuts that they do on the beams, either straight cuts or with a certain slope. And they are applied, again, the DAP, they call it at the bottom of the beams, and the notch is at the top. It applies to many types of beams, not only the eye girders, they do it sometimes in box and camber beams, and we allow, as I said, slope cuts too. And these dappled ends and notches are defined on the beam definition. So you place the beam, you can even place the bearings as such, right? So as you can see the effect here. So let me select the beam group to edit. Right, so skew ends to follow the skew, and then I will just get to the beam definition. So that dappled end or notch could even be specified beam by beam if you need to. So you can select any beam and do it. I will do it in one, but you apply to all beams, it will do it to all of them. And then you specify the notch or the dap being applied at the beginning or end of, at both ends of the girder, right, with a certain length, slope, where you want to apply it, and so on. So you want to apply it at both ends, like I'm doing here. Just one beam or all of them. So say OK. That one single beam that I define, as I said, it could be all of them, are just being cut. And then look, the bearing is modified and adjusted according to the cut or the dappled end at that beginning of that beam. Okay. Now, this is also a refinement that we have done when placed inverted T's. Right, the cap actually was straight, right? But now place it on along the profile. They wanted the top of the T to match the slope of the deck or following the profile, right? So that's one. And also the ledge was only one dimension. Now you can specify different lengths for the ledge where the beams will sit. So you can specify that right on the dialog box. So of course the bearings and will adjust automatically too. So so when you place that inverted T, just let me show you what it has done. Right, so it's barely noticeable because it's not that much of a slope, but then as you can see, it's just automatically following the deck, right? And I specify different ledge dimensions for the T itself, each T or all the beams, right? So where is that done? It's actually on the substructure template. So if I go and edit a particular template, I need to activate that options of ledge and they follow the profile. Right? So I can just put different dimensions and you can see it react. And specify that. So see, adjust it. And now when I refresh, of course, it will be adjusted too. So that length too, and it just moved. So I can save it as a new template or just keep going because I am just adjusting that particular pier. Right? So it will just react automatically at these different dimensions and elevations too. So good improvement right there. Also, now for our reports, right? So they wanted to label the bearings, either automatic or after the fact. adjust the bearings and also rename it as well, right? As you can see in one of the plans that were given to us. So to do that before, you have to do it one by one to all the bearings in your entire bridge. So that we did now is on our dialog box, we include the option to specify a prefix for the bearing names, right? And we can place this from the get-go, and then it applies to all bridge types. So when we place bearings now, we can specify, right? So for example here, uh, abutment bearings. So just for that, specify the bearing, and it will be labeled accordingly, right? So if even after that you need to rename it, you can still rename it if you want, but then we will be one by one in this case. But here are automatically all these bearings for this abutment 1 are labeled with the proper definition, right? So I didn't do on the other ones, but in bearing 1 group, right, I got my bearings. And then, of course, when you do the reports, you will get it with the proper name, right? You can also rename the bearing group if you need to, but the bearings itself are automatically labeled there, right? So this is what we call the bearing labels. So you can rename the group as well, and it's your department 1, and this is part of your ABT bearings now. Before, we used to do this by one, not anymore. Another option that we add for bearings, right, is the option to rotate the bearings, right? So when we place the beams using the beam rotation option, following the deck slope, right? So then the bearings will not rotate. Now they do, right? So it's automatic rotation of the bearing, and of course providing the right geometry information. Right? But the caveat here is you cannot have a grout path, so it's only when the bearings, it is the only component there. So, and it's based on the beam rotation that you select when you place the beams or after you edit. Right here, for example, right? You see I have these box beams with no rotation. That's why you have the hunch here as a wedge. So now I'm going to edit these beams and apply the beam rotation option. And as it's true, it's going to rotate the bearing, rotate the beam, and then it will rotate the bearings accordingly. And then, of course, you will get the right geometry reports based on that rotation. So before it was, there was no way to do it rather than manual modification. Right? More options for bearings here. We got bearing trimming, that's how we call it, right? In which we can just clip the beam seats for cut piers when they were sometimes too big and the pier was in askew, so it was exceeding the width of the pier cap. So now we can just cut it automatically, right? So this is the case, for example, here, right? As you can see, the beam is askew, dimension seems correct, but we need to cut that exceeding option. So now it will do it automatically. And one more time, it will give you the appropriate reports and quantities as the clip is now flush with the deck there, following that skew. So it's just a single option, but as you can see, very powerful, because imagine doing that in every single pier and every single bearing of your multiple span bridge. And saying that now, the bearings, as we used to report, now we can report it as a new unit. We used to do it with volume of concrete. Each now we added surface area for this, right? So as well, I mean, this is just that, right? So this bearing now could be reported as a unit, right? So you can specify here, I'm doing my bearing pay is each, right, as you can see, but now I can switch it to the bearing pay unit to be area. So when it reports, well, it will report by area, right? So it's that. Now, cheek walls. When we place cheek walls, yes, we can place it, but they wanted to see it also as a decorator in the decorator space. So we couldn't do it. Now we can. So it just shows automatically as a decorator, and of course, it's updated automatically, right? So it's just the bottom of the cheek wall. If you have a slope cheek wall, it will show again the bottom of that. It's a new level that we have created, and in general, it's called cheek walls, but a lot of people are using this to display or to generate what they call shear keys. So it can be done. So, and as I said, this is the decorators are created automatically. So maybe it's a good time to rethink your workspace and add new feature definitions and extra level symbology you want to display these elements. So if I add a cheek wall, any cheek wall here, right, it will generate automatically that decorator. So just let me show you a little offset so you can see what is being displayed. And let's see. So now if I update my peer, that bottom, the bottom of the cheek wall should show up in my decoration. Right, so it's there. So now if I go and look, decorate one, I can see my Cheekwall decorator. Okay. Now, as you will see me playing here with the Cheekwalls, I can adjust the height sometimes of the cheek wall, right? Because if I'm doing step caps, I need to adjust the height of the cheek wall, because if not, it's placed at the top of the cap. So I have the option to do that. And also the cheek walls were used to be created vertically or horizontal, right? But now we can use the level top option to just follow the profile at that point. So extra options in our dialog box to control the cheek placement there, right? And this is how we call the cheek geometry options. Again, they are just simple toggles on how we control the level top and the height, width, and offset too. So we can display all of that if I go a little faster here, so you can see what is being placed. So it's just all part of the templates there, right? So that's level top. So that's the one that it will follow the profile or not of that particular cheek wall, right? So, and extra options there to specify offset even. Okay, yeah, that's more illustrative right here. Level top and also placed with a certain offset. Now, we can also name the cheek walls. Before it was just cheek wall 1, 2, and 3, right, and so on. So now in our dialog box, we can specify how these cheek walls are named and apply that on the template. So give it a more explicit name right there, and it's just part of, one more time, the template there. So right here, cheek wall 1. Now I just want to name it my cheek wall. So that will just apply the name to that. So it's just right on the dialog box. And then, of course, this will be part of your reports too. And that's it. That's how you rename it. Now, also, as you can see, enhancements in the substructure. So our step caps now, they follow certain agencies define it with a certain width that they need to be on their standards, so we can apply to that. But this step cap bearing seat width, as you see, it's controlled by environmental variable. There is no way to enter it on a dialog box. It's controlled by an environmental variable, right? A configuration variable, I would say better, and it's just applied to all the piers, right? So you can adjust for that with that. So it's just a setup, right? Pier cap elevations. There's a way now to we report the elevation at the intersection of the alignment and the pier center line. So that's another option to report the pier cap elevations. We used to report it at the corners, right? But now they wanted to see it at the intersection between the alignment and the center line of the cap. So we added on the pier report. So it's an extra column there. And also there is an item type that you can access to do that. So not much to do. It's just part of the report. So, and with the station, of course, of the alignment, and all that. So we can just define that with the options, and it's just part of the report. Right. So I think this was required, but some of our DOTs that are using these as a reference element. So, and I said, this is just part of the standard report right there. So just execute the report, and this is shown, see? And it's called pier centerline reference. All the cap elevations, and that's what it's called, the cap elevation at RL, reference line. Now, a minor enhancement here, but at the same time powerful. The abandoned back wall used to be straight, right? And we define it straight, but then we can activate a toggle to says follow the bridge profile. So that top that was straight, now it can follow the profile slope. Right? On the corbels and offsets too, before we either have a corbel or a horizontal offset. Now we can have both, so we can have corbel with an horizontal offset at the same time. Right, so it's part of the template. So if I go with it, so I can define that option. So I can set up the corbel there, but now I can have that with a certain, the wall with a certain offset too. So place my dimensions there. Offset 2. Right? But then I can offset my wall as well. Okay? So now I got a culvert with an offset at the same time. Piles, we added the option to do an encase pile, but now that is square. So again, just part of the dialog box. More options for the wing walls. I think we missed that. We didn't have the geometry reports are not being generated. Now you have reports for the elevations and piles that are part of wing walls. Right? So we just can provide all the geometry related to the wing walls. So as you generate it and then you request the report, these are all the options and dimensions that you use for the wing wall reports. Okay. What else? Concrete diaphragm for steel girders. Yes, we did have this option. We did have this option on our previous version, but it was not allowing a negative offset. So now, yes, we can just apply that negative offset to that concrete diaphragms, filling up the steel girders. So it's a matter of selection there. Uh, More features for the decorators, our excavation limits as we set up, right? So we created a new level called OBM de-excavation because we now, as we generate the uh, excavation surface, that excavation surface could be also part of the decorators. So just place an excavation, right? The difference now that is going to generate layout at the bottom, right? Showing the excavations there. Let me see. Okay. And now this layout, it's in its own level. So see, it's in red, and that is the layout of that excavation. Right? Fill splices, right? So that's a simple toggle on our fill splice configuration. We allow two options. We allow first the bolt directions, right? Where the bolt is going to show up, or the head of the bolt is going to show up, either outside of the beam or inside of the beam group. That's that simple. And also the control of staggered bolts. So this is something also required, but some of the DOTs in which we can just see how this is being done, left to right, flip the options, uh, or something, they want to remove the last row of the bolts because they are too close to the edge of the plate. So as I said, it's just a simple uh, toggle here. I just created two more fill splices, and one with the flip direction of the bolts, another one with no flip, another one with stag in a positive direction or a negative direction. So basically the way they were going, left to right or right to left. And I will just place both of them, flip with the staggered bolts, no flip with no staggered or negative slope and negative direction, and you will see the difference, right? Rather than explaining to you what is that, you will see the difference when they are placed. I'm going to place it very close together. So let's place our fill splice now. Let's place it on the last beam there, and I'm going to place that one a certain distance, and I'm going to place the other one kind of close to them so you can see the difference. So now let's see how it's being displayed. Maybe if I show it to transparent view. Illustration. Let's see. Let's try illustration first. You see how where the head of that bolt is. On the other one, well, it's inverted, right? So this is kind of the outside of the splice, facing the outside, and in this one, it's flipped. So the head is facing the inside of the beam group, right? And the staggered beams are kind of noticeable too. And right here, you can see the bottom of the flange and the top flange too. You can see how the bolts are staggered. So before there was only the option to do it, row by row. So now we can do it this way as well. Another enhancement that we're still working on is on the parametric cells, right? This is a big enhancement required, especially when you generate digital twins, and if you use parametric cells, right? So now all the geometry is being reported in our geometry reports, including the caps, the columns, for every element that you have. But you have to tag it when you create the parametric cell, right? And it's applicable, as I said, to the piers and abutments. And it also generates item types that you can do. So if all of these is tagged when you create the parametric cell, right? It will give you reports as an item type expressions, volumes, materials, and overall geometry information like elevations. So here, for example, I'm going to place a parametric cell, right? Just with any dimension. And I will apply a material to it, just one or two, so you can see how it's being reported. Let me select it again. Yes. Yeah, for the cap and columns, I'm just going to place one. Right? And remember, when you create a parametric cell, you tag the elements as footing, as piles, as columns. So now when you generate the quantities reports, you would see that on that pier part, right, pier 1, in that case, you see footing, pile, all these elements were tagged, and I can see the computed volume right there. Okay, so more than that, when I go to my input report, I can see the input and the dimensions for that specific parametric cell. If I look for it, support lines, bridge element, let's go to the pier. Supports input. Pier 1. See? And these are what it was used. Right? And also the variables that I was entered when I placed this. In that case, I'm using the default, so. Right? And on the geometry, you can have all the elevations too, all the different elements that you tag. So now if you go into the Explorer, you can see as well all these properties too, or that specific parametric cell. Into the properties and all the options right there. The information that is included, right? And the information that you can change, right? So these are part of the definition when you create the parametric cell. But then also all that information could be managed or exported or used in reports because it creates an item type that you can report on with its proper expression. So, and then you can use it for geometry reports, quantities. You got your options there. At least you got access to these variables and act accordingly. All right, so this is the part of the parametric cells. Running out of time. Very quick, we will add a new workspace. So we always have our survey foot. We rename it the Imperial one now as Imperial Survey Foot, because also we include the Imperial same, but international foot standards. So that require a change on our config files, seed files, and all of that. So we have taken care of that, and you can use it as a basis to update your workspace if you are going to use the international foot definition. Some civil tools that we added now shows up in as our bridge options. We are doing the interaction with OpenGround, right? So it's a new workflow that you can connect to OpenGround. We added a new tab as well in the OpenBridge ribbon, and it's called the drawing production. So before I used to flip between the drawing and the OpenBridge to be able to do plans production. Now we're trying to place it all into one tab, and the most common commands that we use to do plans, we place it there. Hopefully it works out for you as well. Now the full list of enhancements, look, there are 40 enhancements just in OBM. We are going to present it, of course, on the release notes on our LEARNserver and a YouTube page in our channel there, but trying to show you the most relevant ones, right? And just very quick as well, I mean, maybe not doing that much justice to it. This is what is new in OpenTunnel Designer, right? And this is big. This is what we call the TBN Universal Taper Rings, right? The calculation of these panels require very complex calculations because it depends on the rotation of the rings, how you want to rotate it, and not only that, but then the geometry of the tunnel itself, alignment profile. So now we can just software, we can just generate it mostly automatic, right? So when you place the tunnel there, right? If I can go a little fast here. So after you place the tunnel, these are the rings that need to be rotated along the corridor itself. So that complex calculations are done automatically now by the software and can present it to you in a report and also in what extended layout, right? So it's being enhancement required a lot of geometry calculations right there that now these are saved by the software itself. So as we generate the tunnel now, so all these rings will be automatically calculated and their placement of that. So just generate the tunnel and see, right? And this report will be generated too. Let me see, very close here, and that this calculation is the one being generated by the software. Right? The location of that panels are being done automatically too. Right? And of course, the extensive reporting needs that these panels will require. Okay, so every ring, every position, angle, and deviation that is needed. Okay, now we can exclude certain rings, activate many different options right there. And I will show you in 3D more or less. This is what we have, right? Updating all the options and generating the specific report for it. All right. Another enhancements there is the construction scheduler, right? So we can define now construction stages of our tunnel for product management and geotech analysis. And that streamlines the analysis in plaxis and well, provide better information for your construction planning. So construction scheduler is just one more option here and it can be activated. And all these different phases could be set up what you want to build on each part. Right? And the different sections of the tunnel there, and you can be added specifying in what stage needs to be added there. So, and these phases are going to be used when you analyze these in plaxis. Right? Specific number of days. So it's a construction scheduler. Right? So just specify what you're building. Right? More as well on functional components. Right? So now we enhance the use of functional components or parametric cells for our tunnels here. So you can create elements, not just static, but fully parametric in with your placing your sections, right? So you can specify that too. Now, perforators too. So this we call it perforators in general, but it's a modeling of small holes in elements, right? So it's just a matter of increasing the modeling capabilities. Yes, we can do it with MicroStation solids, right? Editing that, but now it's part of the tunnel to generate these fairly automatic. In general, we call it perforators, right? So you can specify that and add it even as part of a parametric component. Let me see. Yep. See? So this is what we achieve with our parametrics there. Right? So now we have the model creation in plaxis, so we can create that, in which we added support for the tunnel boring machines, right, on the tapered rings. So it's just part of that. We account also for construction stages, rock bolts behavior and reinforcement group. All of that information is now being transferred to plaxis, and it just expedites the model creation in plaxis in general, right? So you just define the tunnel with all these options, but then when you transfer to plaxis, all these elements will be transferred, and of course increase the speed and quality of the plaxis analysis, because as all the information is being sent there. Okay, so that's OpenBridge and OpenTunnel. Now, just to show you what other enhancements, because not only we have done enhancements in the modeling part, but also in our analytical elements. So we added specific options now in LeapBridge Concrete for the horizontal shear design. Right? So we also do a skew modification in the design and rating for very specific elements there. So the skew modification factor is being accounted off. The ETA factor as well in the limited state for the substructure design, one more time, being accounted off and being able to specify that. Right? And then generating limited states when you enter the wing load manually in the substructure design in LeapBridge Concrete. In LeapBridge Steel, we support now the concrete diaphragms that are coming from OBM, steel bridges now. Deflection checks at every point of interest, right? Field splice design on the summary report, so we can activate that too. Design checks on the tension flange. Fatigue design check at the cross frames. Now we can visualize the influence lines if you need to. Connection reactions at the end of the cross frames. And I think we don't have time for more. And there is also enhancements on OpenBridge, on the tendon layouts, and some analyticals as well. Again, when we present it on our release notes later when we release the software, as well as I said before, on our LEARNserver and our OpenBridge YouTube channel. So with further ado, thank you.